In this lecture, we discuss about successive differentiation with examples. Successive differentiation is the process of differentiating a given function successively n times, and the results of such differentiation are called successive derivatives. The higher order differential coefficients are used in scientific and engineering applications. Common notations of higher order derivatives of y is equal to f of x are as follows. First order derivative, either we write down f dash of x or y dash or y1, or we can also write dy dx, or sometimes we just write dy. So these are the different notations of first order derivative. Second order derivative, f double dash of x or y double dash or y2 or d2y dx square or d square y. Similarly, we are able to write down nth order derivative as fn of x or y to the power n or yn or dn y dxn or dny. So this is the common notation of nth derivative of the function y is equal to f of x. Successive differentiation of some standard function. First, nth derivative of e to the power x, which is equal to a to the power n e to the power ax. Second formula, nth derivative of a to the power x is equal to log a to the power n into a to the power x. Third formula, ax plus b to the power m, its nth derivative is given by a to the power n, m minus 1 into m minus 2 up to m minus n minus 1 equal into ax plus b to the power m minus n. Here we are considering that m is greater than n. Now, fourth formula, nth derivative of 1 upon ax plus b to the power m. Its derivative is minus 1 to the power n, a to the power n, m plus n minus 1 factorial, whole divided by m minus 1 factorial into ax plus b to the power m plus n. Fifth formula, which is based on the formula number 4. If we put m equal to 1, then we get the nth derivative of 1 upon ax plus b, which is equal to minus 1 to the power n, a to the power n. If m is equal to 1, then this 1 and minus 1 will cancel, n factorial. 1 minus 1 factorial, 0 factorial is 1. Ax plus b, m equal to 1, so ax plus b to the power n plus 1. This is the fifth formula. Now, sixth formula, nth derivative of log ax plus b, which is equal to minus 1 to the power n minus 1, a to the power n into n minus 1 factorial upon ax plus b to the power n. Formula number 7, nth derivative of sine ax plus b, which is equal to a to the power n sine of ax plus b plus n pi by 2. Formula number 8, which is similar to 7th formula, only sine function is replaced by cosine function. And the formula is same, a to the power n, nth derivative of cos ax plus b is a to the power n cos ax plus b plus n pi by 2. Ninth formula is nth derivative of e to the power ax into sine bx plus c, which is equal to e to the power ax into a square plus b square whole to the power n by 2 multiplied by sine bx plus c plus n tan inverse of b minus a. And the 10th formula is similar to 9th formula, only sine function is replaced by cosine function. So nth derivative of e to the power ax cos bx plus c, which is equal to e to the power ax a square plus b square whole to the power n by 2 into cosine of bx plus c plus n tan inverse of b by a. So these are some standard successive differentiation of some standard function. So before solving any example related to successive differentiation, we have to learn all these formulas. Thank you.